guys, your goal is to be able to graph and interpret linear equations that are in what we call slope-intercept form. And so what slope-intercept form means is you can see the slope, you can see that rate of change, and you can see what the y-intercept is. So this intercept that we talk about is the y-intercept, where you cross the y-axis at. All right, so what we have is y equals mx plus b. How many people recognize, hear that, sounds familiar from last year? Awesome, awesome, awesome. M is our slope, M is our rate of change. And so when we think about that in terms of the toothpick problem, we had 3 toothpicks for every square. So we have 3 times x, 3 times the number of squares we have. B is the y-intercept where you cross the y-axis. That's why we had y equals 3 toothpicks for every square plus that 1 that we have to start you off with. I have to start you with 1 toothpick, and then you can add 3 to keep building from it. All right? And so what we want to be able to start with before we can graph is to simply look at an equation and pull out m and b. Well, what we have to remember here, ladies and gentlemen, and we did this way back in chapter 3, in order to find slope and y-intercept, it has to be in function form. And so what that means is you have to make sure that you solve for y. Okay? Now sometimes they'll be nice and give you y equals. So here we have y equals 6x plus 4. So y equals 6x plus 4. If I look, I've got y by itself. That means I should be able to pull out my m value. So my m value is 6. What's my b value going to be? What's my y-intercept going to be? 4. It's plus 4, so that means my b value is a positive 4. If we look at b, do I have y by itself? No, I've got y minus 9x. How do I get y by itself? Will? Beautiful. We're going to add 9x to each side. So we have y equals 0 plus 9x, guys, is really just 9x. So I should be able to look at this equation and pull off my slope. Mike, what is the slope? 9. What is my b value? What am I adding on? Where did I start at? 0. 0. Ladies and gentlemen, if you're not adding anything to that 9x, that means you're starting at 0. We didn't have to add anything to the 3x. We would just have y equals 3x. We had to add that 1 because we had to start with 1 toothpick. Here, we don't have to start with anything. It's just 9 times x. So it's like a box of donuts costs $9. So it's just 9 times the number of boxes of donuts you buy. There's no beginning cost there. So if there's no beginning cost, then our b value is 0. See, guys, y is by itself, but we don't really like that expression there. I want to have separate terms for each of those, which means I have to go through and divide each of these by 2. So I need to do 1x divided by 2. So that's y equals 1/2 x. I need to go through and divide negative 8 by 2. And so that's minus 4. We saw that a little bit in chapter 2 when we were doing the review. Okay, but what we need to keep in mind, guys, is we did this when we were solving for y. Everything on the right-hand side has to be solved and has to be divided. So 1 divided by 2 is the 1/2. 8 divided by 2 is the 4. So, Devin, what's my slope for this problem? All right. Think of that in terms of like the road. You go up 1 foot for every 2 feet across. So that's what a fraction slope would mean. Let's see. What's my b value? 4. Excellent. Because it was minus 4, you have to write it as a negative 4. Ladies and gentlemen, this seemed pretty much a review. Excellent. Let's keep going. All right. Parallel lines have the same slopes. Okay. They may ask you guys a little bit about parallel lines today. If not today, then tomorrow. An example of parallel lines would be y equals 1/4 x plus 7 and y equals 1/4 x minus 1. They have to have the same slope, so the only thing I'm focused in on is that 1/4. Okay? We could have used any slope, guys. We could have used 1. We could have used two positive slopes. We could have used 2 negative slopes. We could have picked any b value we wanted here. Okay? If you wanted to be crazy and put 75 over 942, that could be your b value. But when I ask you to give me an example of parallel lines, I simply need them to have the same slope. So we need to figure out, are these equations parallel? Are the given sets of line parallels? Explain your answer. So when we look at the first one, I've got y equals. When I've got y equals, I can pick out the slope. My slope here is 3. Do I have y equals on this one? Well, I've got y minus 3x equals -4. I don't have y by itself. So in order to determine whether or not they're parallel, I have to have y by itself. I have to have it in y equals mx plus b form. So I'm going to add 3x to each side. Now when I look at this, I can see that I have a slope of 3. So my answer here is obviously yes, because they have the same slope, and that's your explanation. Yes, because they have the same slope. All right, ladies and gentlemen, at your seats, I would like you guys to figure out, is section B, example B. Let's get at your table for the first equation. What's the y equals mx plus b? What did you guys get for your first equation in y equals mx plus b?
Y equals -3x plus 1.
How many people got y equals -3x plus 4.5? You've got to remember, guys, that 9 has to be divided by the 2. Everything gets divided by the 2 with the y. Andrew, what did you guys get for the second equation?
Y equals 3x minus 4.
How many people agree with y equals 3x minus 4? Beautiful. Keep in mind again, guys, if you still have a 12 in your problem, you've got to take every term and divide it by the y coefficient. So, yes or no, are these lines parallel? Marcus? No.
The first equation's x is negative, and the second one is positive.
Okay. Ladies and gentlemen, it's not just good enough that they're both 3. They have to be exactly the same. And so negative slope would be going down, positive slope would be going up. They would eventually intersect, which means they are not parallel. So no, because different slopes. All right, ladies and gentlemen, I believe the next 3 problems are on your own. So at your table, let's finish those. Guys, let's take a look at what we've got up here. Number 1, slope and y-intercept were already there. It doesn't matter which side they're on, the left or the right. As long as y is by itself, I can pick out m and b. So we should have m equals 4 and b equals -7. For number 2, I have to solve for y, and so you have to go through and you're going to have to undo that subtraction. So you add 8x to each side, and then I have to go through and divide. 8 divided by 9 is 8/9. Keep it as a fraction so that you have rise and run. And then -3 divided by 9 was -1/3. So my slope was 8/9. My y-intercept was -1/3. For number 3, I have to solve for y. It'd be really nice if I could just solve for x, right, guys? But I have to get y by itself. So I add x to each side. I go through and divide by 2. Remember that this is a 1 here, guys. So 1 divided by 2. 1 divided by 2 is 1/2, and 6 divided by 2 is 3. Here you simply have to divide everything by 4, and 2 divided by 4 is the 1/2. 16 divided by 4 is 4. I'm only looking at the slopes, so yes, because they both have m values of 1/2. All right? Guys, that's the stuff we start with. We start with being able to identify M and B. What we want you to be able to do now is actually make graphs with those. So this is a big part of what you're working with today is just finding M and B. The next part is actually taking the graphs. So you want to rewrite the equation in function form, just like we said before, solve for y. Then what you're going to do, ladies and gentlemen, is you're going to plot that y-intercept. That's your starting point. So think back to the toothpick problem. You had to have that one toothpick before you could start adding 3 on. So you have to start with your B value. This is always your starting point. And keep in mind, we call that the y-axis because that was the toothpick you had to start with, guys. So going back to that toothpick problem, guys, you had to start with one toothpick. Put that on the y-axis. Then you count your slope from the B value. Okay? You start from that one toothpick. You don't start back at 0. You start at one toothpick and then add on. And I want you guys to get at least 2 more points. Okay? We'd like to have neat graphs. The more points you have, the neater they are. So if you don't have access to a ruler, you need to have a lot of points. And then you're connecting your points. We're making continuous graphs. And then make sure the direction of your line matches the slope. So positive slope should be increasing when you look at your graph. Negative slope should be decreasing. So ladies and gentlemen, all these little notes I write here, you guys should be putting those in the margins if you're not already doing that. Now some of you are good at graphing, so we don't need to worry about that. But those of you who are feeling a little bit anxious, all of these little things I put in here should be showing up in that margin. All right, I'm going to go to a split screen, and we'll take a look at graphing. All right, so I went to graph the first one, y equals 2x plus 3. Awesome, y is by itself, so I don't have to do any solving. I'm going to start at my b value, so I'm going to start at positive 3. So 1, 2, 3. It then said to count my slope, so I have a slope of 2. How do I get that 2 as a fraction so that I have rise and run? Kenny?
2.
All right, so Mark, now that I know it's 2 over 1, how am I going to do rise and run? Beautiful. Up 2 over 1. Guys, I have some juniors that are still struggling with that. And what I try to do to help them is read that fraction as 2 over 1. We often read fractions that way. 1/3 is 1 over 3. 4/3 would be 4 over 3. If you read this as 2 over 1, you automatically say that 1 is your over move. So then I'm going to go up 2 over 1 again. I'm not very neat on the smartboard, guys, so I'm going to keep making points. I want to be neat here, so that means I'm going to go down 2. But to line up, I'm going to have to go back 1. I've got to do 2 negative moves to keep it positive. And you guys kind of did that on your chart with the toothpick activity. So there we have it. How many people end up with a line that looks very, very similar to mine? Okay, it better look exactly like mine. Kira, is y by itself for b?
No.
No. So what would you do first to get y by itself? I'm going to subtract the x to cancel it out. Be careful here. We kind of want to ignore the minus behind it. And if it's a positive x, then subtract it. Okay. Let's try this. Okay, sorry, this is not wanting to cooperate for me over here. So let's just start typing. So I'd have negative 5y is equal to, was it 10 minus x? Is that what I had there? All right. So 10 minus x. What are we going to do next here, guys? Divide by negative 5. Let's see if I can start writing now. So if I divide by negative 5, this cancels. I get y is equal to negative 2. What's this going to be? What's this negative x divided by negative 5 going to be?
It's going to be a positive 5.
Positive. Is it going to be 5x or 1/5 x? 1/5 x, guys. Put the ones in front of your x if you can. So I should have plus 1/5 x. Cheyenne, where am I going to start my graph at? Good job, guys. It doesn't matter what comes first or second. The b value is always the constant, so start at -2. It's a positive slope, so I'm going to count up 1 over 5, up 1 over 5. That kind of makes my entire right-hand side, so now I'm going to go down 1, and I'm going to go back 5. I think the board is not good. And I'm going to go down 1 and back 5. And then we can draw in our line. Ladies and gentlemen, I'd like you to try the on your own. You're obviously going to have to solve for y. When you're done with that, guys, you're going to do page 244. You can write that in the assignment line once you've raised your hand and I've checked your graph. Numbers 15 through 51 multiples of 3, which means you're going to skip every other problem.